Let's discover how Archimedes' principle explains floating and sinking in water and other fluids. Section 1 for kids. Have you ever wondered why your rubber duck floats in the bathtub, but a metal spoon sinks straight to the bottom? Archimedes' principle helps us understand this. When you put something in water, the water pushes up on it. This is called buoyancy. The bigger the object, or the more space it takes up, the more water it moves out of the way. If the push from the water is stronger than the object's weight, the object floats just like your duck or a beach ball. If the object is heavier than the push, it sinks like the metal spoon or a stone. Think about swimming in a pool. You float because the water pushes up against you. Icebergs float in the ocean for the same reason they are supported by the water's upward force. Section transition. Now let's look at how Archimedes' principle works for adults. Section 2 for adults. Archimedes' principle states any object fully or partially submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid displaced by the object. This principle applies to liquids and gases. For example, ships float because their hulls displace a large volume of water. The upward buoyant force equals the ship's weight. Helium balloons rise in air because they displace air heavier than the balloon itself. This principle is vital for designing boats, submarines, and hot air balloons. Submarines control their buoyancy by taking in or releasing water, letting them sink or rise as needed. Scientists also use Archimedes' principle to measure the density and volume of objects. Finale. From playing in the tub to engineering ships, Archimedes' principle helps us understand the simple reason objects float or sink in fluids, making science part of everyday life.